One notes, so we're going through 5.1. This is polynomials. Okay, polynomial is, we're talking about expressions, not equations still. We're still not using the equal sign yet. A lot of definitions and different, I don't want to say terms because that's actually a definition, but different, I guess definition is the best thing to say, of term, polynomial, and different things you need to be familiar with. Okay, so I'll just start with the definition of a term. So a term is an expression made for multiplying a number by another number or variables. So example 9x, okay, or a constant value. So 5. Okay, so anything that's like a group, a little product. Okay, but also a constant counts as a term as well. Okay, a polynomial is an algebraic expression made of one or more terms connected by addition or subtraction. Okay, so 3x squared minus 4, that's 2 terms. That's a constant. That's just a normal, we just call that a term. A constant's a number without a variable. The reason it's a constant is because the word constant means constant. It stays the same. Well, if nothing's on a 5, variable-wise, it'll never change. It's always the 5. Okay, so a constant is a number because of that purpose. Okay? All right. Types of polynomials. So here's one I want you to highlight because I want you to be familiar with this. A monomial, mono, okay, mono y mono if you want to use that in your mind. Okay, that's one term. Okay, binomial, okay, just like bilingual, okay, 2. Trinomial, triangle, 3. And then anything with one or more terms is called a polynomial. So all of them are polynomials. So like a binomial is a polynomial. A trinomial is a polynomial. But once we get past 3, we generalize them all as polynomials. So if you're at 4, we just call it a polynomial. Okay? Questions there? Okay, so going through these ones here. Bree, how many terms and what would you call it for A? Binomial, so it's 2 terms. And it's binomial. Good? So it says write the number of terms and then state what type it is. We just did that. Okay, and then Evan, how about B? Trinomial. Good. And so that means 3 terms, right? 3 terms, trinomial. Okay, Cato, how about C? Polynomial. Because it's more than 3, it's 5. Okay, again, we're getting this by counting. So 1, 2, 3, 4, 5 terms. 5 terms is bigger than 3, so we don't have a specific name. We just call it a polynomial. Okay, and how about Caden? What about 13? It's 1 term. And what's that called? Monomial, correct. Okay? So right now we're laying the groundwork, guys. We're laying the groundwork. So this is going to be assumed later. So what I mean by assumed, this is going to be assumed knowledge. Okay? It's going to say, what's the binomial have in terms of degree? You're like, well, shoot, I don't know what binomial is. I don't even know how to do degree. Okay? You need to know what binomial is. Okay? So, show you know. Just kind of keep going around, keep everybody involved here. So, Duffy, what is the number of terms for A on the show you know here? It's 1 term, so it's a monomial, yeah. Okay, it's a monomial, 1 term. Remember, I know some of you are like, wait, there's a 5 and a J, but they're still a product. They're 1 product. This right here, I could do this. That's still 1 term. Because 1 big product, doesn't matter. It's 1 term still.
So if you go 5 plus j squared, that would be...
Right, so if it was 5 plus j squared, that'd be 2 terms. Is that what you're saying, Nolan?
Yeah.
Yep. Okay, Hudson, how about this one? How many terms? 2 terms. And so what do you call it? Good. Okay, C, Connor.
3 terms.
3 terms. Trinomial. Okay, Emily. 4. Have some confidence there. Okay, and that we just call a polynomial. Okay, and Jade, how about E? 3, correct? And we call that trinomial. Okay, very good. Okay, if you're a notes person, this is the most commonly rule that is missed on the exam. Degree of a term. 80% of finding the degree of something is super easy because it's just straightforward, but there is one issue where you have to make sure that you understand it, and that is these examples. Okay, so let me explain. Okay, everybody's highlighting and ready. Are you ready? The degree of a term is the sum of the exponents on the variable in a single term. So what that means is, you look at, so for example, this right here is a single term. What's the exponent? It's a 2. So this one's degree is 2. So it's just the exponent, no problem. Now where it gets difficult is this part, where you have 2 variables. This is where people mess up all the time. See how it's 3xz? Well, they both have 1s, right? You add them to get the degree. There's 2 variables, you have to add the exponents. So it's 1 plus 1 for 2. So the degree of 3xz is 2. Okay, so look, 3xz's degree is 2 because a 1 and a 1, we add them if there's 2 variables. So let's look at the second one they have. 5x squared y. I have 2 variables, so what do I do with the exponents? Add them. So you said add them, Mr. Banker. You just told me that 30 seconds ago.
What about the last one, the example?
Yep. We'll get to that, okay? Okay, 2 plus 1. So this one's degree is 3. 3, that's why they have 3 there. Okay? So when there's more than one variable in your term, you add the exponents of all the variables you have. Okay, so let me do a little bit harder one here for you. Okay, that's one term. 6. 3 plus 2 plus 1. So my degree is 6. You guys got that? Good. Yes, sir.
What if you were to put plus 1? Would that 1 still have a...
That's still last one.
Okay, so like this one kind of?
Yeah.
Okay, good question. In order to have a degree, you have to have a variable. Any constant's degree is 0. This is why. So 6 does not have a variable, right? Yeah. Let's just pretend we're going to write, let's say we want to write it with a variable. It'd be to the 0 power, right? What's anything to the 0 power? 1. So it's really not even there, right? So in reality, a constant degree is 0 because it has the variable but to the 0 power, even though we don't see it. But if you like, just because it's no variable, no degree. You could say that as well. So no variable, no degree. So to this one that Nolan's asked about, 5x plus 6, the constant has a degree of 0, so the whole thing is 1. It's 1 because of the x to the 1 there. So that 5x, x has a 1 on it, that's the degree. 6 doesn't have a degree, so it's 0. 0 and 1, the biggest is 1, so you always take the biggest one, which in this case is silly because it's just 1. We'll do some more. But like I said, this is the one that's most commonly missed. I had one too many coffees, I'm all jittery. Need to cut back to 1 coffee a day instead of 2. All right, the degree of the term with the highest degree, that's the degree of the polynomial. So when it says what's the degree of the polynomial, you want the highest term degree. Okay, thanks. You want the highest term degree. So example, if I want the degree of the polynomial of 7a squared minus 3a, this one's a 2, this one's a 1, so the degree of that polynomial is 2. That's the highest number. Okay? Does that make sense? So if I say degree of polynomial, you look at all your terms, you find all the degrees, and you say the highest one, that's the degree of the whole thing. The reason being is what grows faster, an x cubed or an x squared? A cube does, right? It goes really fast. What goes faster, an x5 or an x3? An x5. So what I'm telling you is the kind of like the biggest exponent trumps the rest because it grows so much faster. So we call that the degree, okay? So let's look at these, and we'll figure out these examples here. All right, so for each expression, find the number of terms and the degree of each polynomial. So this one, 2 terms. What's the degree? 2, good, just a 2. Okay, this one has a 2, this is 0. I like to write them on top so I know. Oh, 2 is biggest, there we go. B, how many terms? And then you go through and you go, okay, that one's a degree of 2. 1 plus 1, 2. 2. Oh, they're all 2, so then the degree's 2. Because 2 is still the biggest number. Okay, since A just came in, this one's a 2 because if you have 2 variables, you have to add the exponent. So 1 and a 1, 1 plus 1 is 2. Okay. All right.
So if there's the one in it, like the 2AB, you just add them together and make it 2.
Correct. Okay, 5x plus z minus 6. That's 3 terms. 1, 1, 0. So degree is 1. Seven, 1 term, degree is 0. Questions, concerns yet? Comments, complaints? Yes, Brett.
Yeah, I'm still not so sure how you degrees then?
Yeah,
From what you explained.
sure, absolutely. Okay, so one more example of a degree. So if I'm asking for a degree of a polynomial, okay, so that's a harder polynomial. Okay, so what I need to do is if I'm going to degree of polynomial, I need to look at all 3 terms. I have 3 terms, right? This is the easy one. There's no variable, Brett, so this one right here is a degree of 0. Okay, if there's no variable, that's the degree. This one, it's x and y. They're both 1s, so what do I do with the 1s? We add them. When there's 2 variables, you have to add the degree, add the exponents of each. So this would be 1 plus 1, which is 2. If you're saying I don't see the 1s, they don't write them there. They're there, though. Okay? And then this one, it's x1 and y2. So 2 plus 1 is 3. So the degree of this term is 3. The degree of this term is 2. The degree of this term is 0. The biggest number I have is this one, so the degree of this polynomial is 3. Okay? Click a little better, Brett. Do you want a couple more? We got more coming. We got some charts coming right here, so this will help. Okay? Okay, so I'm going to try to get through these here, so make sure Liv gets all the notes here. Okay, so expression 1 minus 3x, it has 2 terms. And then look what it did for you. Degree of each term, 0 for the 1, 3x is 1. So the degree of the polynomial is the bigger number, which is 1. Sure. Okay, this one, 1, 2, 3 terms. Degree of each term, the first one, 1, second one, 2, 0. 2 for the whole thing, because it's the biggest one we have. Why is it 2? It's an x and a y1. These are both 1s. We add those. Number of terms, 1. Degree of each term, just one of them is 2, so it's a 2. One, 0, 0. 0 for constant. All right. Questions, concerns? All right. Okay, so model each polynomial using algebra tiles. So I'm not a huge algebra tile person, but algebra tiles do help visual learners, so I still go through them a bit. This is what they look like. Positives are dark, whites are negatives when it comes to algebra tiles. Okay, so it says model it with algebra tiles. So 3x plus 2 with algebra tiles would just be 3x's shaded, and then 2 units shaded. Just practicing modeling that. So my thing to you guys, you don't have to do your work with algebra tiles, but you have to be able to read algebra tiles. That's the expectation. So on your test, if I put this picture, you should be able to say, hey, that's 3x plus 2. Okay, but you don't have to do work with them or add or subtract with them yet. Make sense? These, because see this right here? X is the longer. The little cube's the, see what I'm saying? So that's 1 unit, 2 unit. These, 2 of these, and then 3 of these. Yep. Okay, anything else? Okay, good. Next one here, we'll do a couple more, and this is the last page, so we're finishing up here. Okay, so an x squared, it's a white one because it's a negative x squared, so it's a white box. Minus 2, so 2 white units. That's it. You keep them white because they're both negative. And so you can also see here that you have 2 terms. Okay, I have 1 term, 2 terms. Okay, if you want to practice, the degree of this polynomial is 2. Okay, and then C, 2x squared, so I have 2 shaded bigger squares. I have a 3, so 3 units. They're dark as well. And a negative x, so 1 white bar. Okay, we're on the decline. Okay, they'll have to wait. Okay, so model these ones. White box. 4 dark bars. Okay, and then 3 white. Okay, and the last piece, we're writing this expression. So I have an x squared, 1, 2, 3 x's, 4 negative 1s. X squared plus 3x minus 4. Okay, just reading the tiles. Okay, and that's it for lesson 5.1.